and welcome to the second live demo session of the nezo design efficiency solution, the only application out there for architects and engineers to help you reduce design time, project costs, and carbon emissions. If you're watching from LinkedIn, there is a 30-second delay on that LinkedIn feed, probably because they realize that both of us are Irish and we have the tendency to drop in F-bombs that they want to remove. So I'm sorry, we won't be able to answer questions live, but if you do in the comment section, we will get them, and what we'll do is we'll address those at the end. If you could also just drop in a like or some sort of an emoji there, just to let us know you're there, because we can't actually see who's actually online. We do see the numbers, we just don't see who's actually online with us. We're delighted that over the last session, we had over 200 users or 200 attendees attended across all the platforms we're streaming on, which includes LinkedIn, Instagram, Facebook, TikTok, and YouTube. So please spread the word about what we're doing and tell people they can log on and see a demo of what we've actually been working on. I'm one of the co-founders, Barry, and I've also got my co-founder, Rowan, who's on the opposite screen. He's going to be running the demo. I'll do just a very, very quick, no fluff introduction just to make sure that you're on the right flight. We don't end up with all of us at the wrong destination. So I'll just give you a quick, this is exactly what we do. So we're all here because you're interested either in design efficiency, cost or carbon outcomes, or decarbonisation, or making carbon reporting easy. So that's exactly what nezo is. We are a design efficiency solution that does carbon analytics. We're not just a carbon management tool, we do so much more. We seamlessly embed weight data directly into your existing workflow and into your existing software, so that you can always see how your design is performing from the earliest stages of design, and show you where you can do better. You can get better outcomes, and when you can get those better outcomes by swapping in materials in and out rapidly and seeing what the actual impact is on your project. It works with Revit, SketchUp, and ArchiCAD. And if you're a designer that has lost time or hair from carbon compliance reporting, as Neighbours has been released for that mandatory carbon compliance reporting process, or you've lost time in specifying the material that just didn't provide you the impact or didn't work for the project, you spent all this time learning it and then you tried applying it and it actually just didn't give you the impact that you were looking for, or you're absolutely frustrated and tired of redesign loops and value engineering workshops that don't actually reduce costs, they just eliminate value from the project. Extremely frustrating. And then the last, maybe better outcomes. You want to reduce carbon emissions in your projects, you want to reduce the cost of your projects, or you want to reduce the rate, which actually creates opportunity in your projects. You've had users that have eliminated one particular project $750,000, which was an increase of profitability margins of 16%. They also reduced their weight of their building by 1,000 tons, which allowed them to build 2 floors higher and increase the yield. And they reduced their carbon emissions by the equivalent of planting 180,000 trees on just one project. We've had another architect who had a really difficult site. They were on the 3rd iteration of design, and every single design was too heavy for the ground conditions that they had. Their application to come up with a methodology that actually reduced the weight of their building, allowing them to actually get into construction and build that building. We've had another architect who just wanted to simply understand how they were performing. I'm going to hand it over to Owen now. He's going to run a very quick and very high-level 15-minute demo of what the application actually does and how it gets you those advantages when you're designing. And if you do want something a little bit more detailed or in-depth, either ask us a question here, we'll try and get into it in a bit more detail, or I'll flash up a contact page at the end where you'll be able to just click the link and maybe log on with us and get a more detailed demonstration. I'm going to hand it over to Owen now. Owen, you work away, mate.
Yeah, thanks, Barry. Hello, everyone. So look, as Barry has said, this is a quick demonstration. Fortunately, when you design a solution or provide a solution that's intended to save the architects and engineers out their time, it actually goes hand in hand with being pretty fast to run through. So what I want to get across today ultimately is how fast this solution is to get the insights that you need to achieve all those good things that Barry just mentioned, and ease of use. I think I just want that to carry through as well. So we'll run through the workflow from source of data in design software, how it integrates with nezo, um, again within your design software, and ultimately ending up out in the neighbors tool for that embodied carbon life cycle analysis, which does form part of SEP legislation for all you users in New South Wales. Okay, cool. So with that workflow, as I said, ease of use to get to a point where you can get cost insight for the cost of your materials supplied and installed, upfront embodied carbon emissions, your stored carbon, and weight, as Barry mentioned, can be incredibly important for that commercial construction. And also how you can actually compare design options for your building to identify, substantiate what is the most optimal solution for sustainability, but always keeping an eye on budget as well. Cool. So for the demonstration, I am going to show you guys the workflow from the perspective of Revit, but this works exactly the same if you are in ArchiCAD. For all you ArchiCAD users, you'll be familiar with the demonstration model there. So nezo works the same across that platform, and in SketchUp as well. SketchUp, very importantly, comes into its own for that early stage design analysis, and nezo provides all of the data and tools you need to work from the very beginning at the earliest concept stage to make decisions. Decisions that are made earlier ultimately will achieve 80% of that carbon emission saving, things around core structure of the building. But as you can see here, SketchUp is actually very capable as well as for handling even the more detailed models as well. So jumping back to Revit, the first thing I'm going to do is talk about the data. So cool, you need quantities of materials used in your model. That's one facet. I'll show you how that just comes into the workflow naturally, and we'll show you how we capture that. The other part is, cool, you have a quantity of concrete, a quantity of timber, even quantity of carpet. What do you do with that data to understand its cost, its carbon emissions, and its weight? Well, cost you need to currently go talk to suppliers. For carbon emissions data, neighbors have fantastic resources. You can go to the neighbors EPD list, which is all the environmental product declarations from the various suppliers. There's hundreds and hundreds of EPDs there, thousands in fact, showing you that a cube of concrete from such a supplier has X amount of emissions. They also have emissions factors there as well. And for anything not on that list, you can visit Australasia EPD. Problem there is you've had to quantify the material, put that data on a spreadsheet. You've then had to go and find that emissions data from whatever source it was in, bring it into your spreadsheet and keep running these calculations till you tally everything up. Now, nezo brings that to where you are in your design software and automates 90% of that, 95% of that workflow. So we make it accessible. Right now, I have nezo open inside of Revit. So I'm never leaving my design software. I'm never leaving Revit, never leaving ArchiCAD. There's no IFC export import. It all happens where you are. I've opened up the application and I'm brought to the materials database because we don't have to think about data in it's an EPD, it's emissions factor. Just think the way you're already thinking with your existing workflow. What material am I specifying? It will give you the insights into cost and carbon. So what you'll find here is the same data you'll find in the neighbors EPD list or the neighbors emissions factors, which are built into the embodied carbon tool. We can come down here and we have every EPD for every product that's available. Now, this is fantastic, but to just use EPDs alone, now apologies, I do switch between a few different screens and tend to talk a bit fast, so we can go into any more detail anytime anybody wants to see this again. But I'm just going to jump over and show you if I was to use just these EPDs and a design software workflow, I'd be required to model the concrete in the footings, the timber piles, the bears, the joists, the insulation, the strand board flooring, and everything that's included. So what we've done is we've then brought these EPDs together and the cost information for all these things that would be in a floor system, a wall system, a roof system, as well as adding cost and extra data to things like steel beams and all the sundry items that would come with that. And we've made them into what we call nezo materials. So you can still access the specific carbon data for each EPD that you would find in neighbors now inside of your Revit or ArchiCAD, but with the nezo materials, We can use cubes and squares and still quantify all of that material, but very, very quickly. Instead of modeling that floor, I can simply draw a rectangular slab, apply an iezo material, and I'm able to generate all the quantities for that insulation, for that concrete, for that treated timber. And when I export out, now that takes 30 seconds. When I export out to the neighbors tool at the end of this process, I still see the volume for each of those materials. So full transparency, this is not a black box. So what I'm going to do is bring in some of those composites or nezo assemblies. We can come into frame, we can go steel columns, we can find anything we need there. We hit import, and we'll see down here in the bottom corner, material created. For you ArchiCAD users, it's the very same. You import, cherry pick from this list, import a material, and you'll see that material is created. It's now available in that file. You use that as a material in your model. So now you don't have to think about quantification and data analysis. It will happen for you because nezo will understand what everything is simply by understanding the material that's been used. So I'll show you a quick map or how I might embed a material. We are going to bring up an upper floor system. This particular model I have behind me is a core structural model. It's a good detailed model. This is a retrospective workflow where I'm applying materials to a building that's already been modeled. Ideally, you would do this, you would embed these materials from the very beginning of your design. You would even have them saved as templates or in the family groups so that when you're modeling, you have the wider team in the office modeling, designing these buildings, and passively generating cost carbon weight insights without even essentially knowing. Anytime they upload to the nezo application, they get that data feedback. So there's a lot of CLT in that floor, or in that model. So we'll bring in a CLT floor. I'll just show you how you put that in. I'll pick one of the options here. Import. That material now is available in the model. And let's just select that, and we'll go to projects. Now I'll only map the one material just to keep things fast, but brought in a CLT. Now the workflow is cool. We have the material there. So the workflow with applying materials, mapping materials with nezo is very flexible. We've spoken to thousands of architects and engineers. I still think I haven't met two that work exactly the same. So whether you're working with existing composites and you only want to put one nezo material in, whether you want to use a selection of detailed nezo materials and build up a composite comprising of those, or you just want to use a slab tool and put the nezo assembly material over the top to do all the quantification for you because you want to work early and in a low level of design detail, you can do it that way as well. That's the fastest way. So we work very flexible, and generally everyone will find their own method of how it works for them. So just switch over here to Australia. I've already created a project. So I found my data. It was accessible. I used it as a material. It was usable. And all of the build-up for a system is built into one single material if you're using one of our assembly rates, meaning it's fast. The other thing that's fast is the quantification and the data results. So we're going to create a building variant, option 1. So everything that you have on your 3D model, and it depends on what layers you have on and off, and you can control your building options that way, but everything you see here, the application sees. So I'm going to link and I'm going to sync that model. So I've embedded materials. I could have brought in concrete, floor systems, wall systems. Once I upload, the system recognizes that. It understands the quantities of all the materials used in your design. It references it back against that database that's driven by cost information provided by us and the carbon emissions data that's provided via the neighbors database with additional EPDs that we've added from EPD Australasia, and it's going to give you the results. So we'll just click out and back in just to speed up that refresh. And we're going to start to see insights appear. It's decided to run a little bit slower today. There we go. Okay, fantastic. So the first thing that always happens when you run an upload So now you can see the model has appeared in screen on the dashboard. Again, we haven't left Revit to do that sync. The first thing that's always going to happen is a material quantity takeoff is going to be automatically done for you. Now it's very visual because you designers out there are very visual people. You want to explore data. You want to click around on a model. You want to understand, cool, here it is. There's 2 cubes of CLT in that wall. If I click that, it's going to show me where the rest of that material is used. That's fantastic, but they're just quantities. That material that I mapped, which was the floor system, has actually been categorized. It's brought up, it's now under an elemental category of upper floors. And when we click here, not only do we see where the material is in the model, we can actually see the total quantity, the total upfront embodied carbon emissions, the stored carbon, the weight, and the cost of that material as well. So it would take about 5-10 minutes to work down through this list with these materials, but you can go as detailed as you want or as simplistic as you want with the level of detail that you're using. Now, I don't have to just embed materials like I showed you. What I can also do is map materials. And this is a fantastic workflow for people looking at previously completed projects that they want to get carbon profiles on, cost profiles on for their future benchmarking. So let's click on what we have here, which is a precast wall, and I'm going to map that. So I'm not working in Revit in this case, I'm mapping inside the nezo tool itself. And you can use, as you can see, you can use a hybrid of both workflows. So we'll come down and we're going to use another nezo material here. So we will go to structural walls, precast walls, and we'll find the option that we need. So there's a variant for everything. If it's a wall system, you go to external walls, you choose the cladding system you want, say it's a brick cladding, and from there there'll be options for steel frame, timber frame, what spacings those studs are going to be at, what R value the insulation is there. So we have 2,800 EPDs from neighbors, and then we actually have brought them together into assemblies that you can use to speed up your workflow. And there's about 6,000 of those in the library at the moment. And you actually can create your own assemblies as well for any variant that we haven't already thought of. Cool, so now what we've seen is we have another structural wall item here. So we have structural walls and upper floors. We're very quickly building up an elemental schedule of quantities that doesn't just have cost, now is carbon, and now is weight. I can select on one single piece of concrete wall there and get feedback on the emissions, the carbon emissions, the weight, and the cost of that as well. So what that looks like towards the end of the process is a fully detailed version like you see here. Let's just click down a level into that. That was the summary page. That's where I can platform different materials on different building options, load them as separate variants, and compare them against each other so that your decision maker, your client, can see that you've made the data-informed optimal decisions for good outcomes for your project. So cool, when everything's mapped, again, it's such a quick process. We're able to quickly navigate down through this dashboard, see where the materials are, see what you might have missed, and understand hotspots. Where's high in carbon and high in cost? Because likely those items have a potential to reduce one or the other. So that's leading to an optimized design. You get the feedback here, then you platform alternative materials back on your model and load them as variants. The summary page within nezo will then be able to identify very clearly and quickly to your decision makers why you've swapped, in this case, potentially a concrete floor for a CLT floor. Now, one thing to note for the architects and engineers will be thinking at this moment, how easy is it to swap those materials? So if I was in the build option here for concrete, and this is kind of an important example, so that model's loaded up. We have a concrete floor here. It's not terribly high in cost in comparison, but it does have high carbon emissions. So we want to quickly understand, is it worthwhile designing and investigating if we were to swap this out for CLT, for example? Now, the problem is this has been modeled at 150 thick slab. Now, the CLT might have a different thickness and it has acoustic and fire requirements. So you're thinking, cool, I can compare one to the other, but I'm going to have to go back and start to remodel. I'm going to have to change the thickness of that slab to suit the CLT thickness so I can quantify the volume of timber. I'm going to have to model in a floating floor for acoustics, which has cradles, rubber cradles. It has battens, insulation, strand board flooring. So all of that you do not have to do. You can simply copy that floor, put it on a different layer, the concrete floor. Don't worry about the thickness of the slab. Don't worry about modeling the rubber, the battens, the insulation. We come down back to the nezo materials. We'll go to upper floors. We can see that there's an option here for cross-laminated timber with floating floor. We'll use a meter squared rate. So it doesn't matter. You're putting that on a slab. We will pick up the volume based off the thickness because you choose the thickness from the description. Now, when you export out at the end of this process to the neighbors tool, you will actually see line items that include the insulation, the rubber in those cradles, the plywood. All of that is fully quantified. They're not just generic numbers we put on these based off of square meters. There's first principles build up for both carbon and cost. So cool, you've identified using the platform all of the hot spots. You've platformed different materials. It's now worthwhile talking to your wider design team to investigate those because nezo gave you good feedback that there's good outcomes for your project. You've got sign off on the most optimal solution. And at this point, you can simply download the neighbors report. So you've done your design optimization. This all happened at the earliest stage of design. You've brought it right through to consent stage, and now you can download a neighbors report. And this Excel document, which is required under SEP legislation, will download directly to your desktop. Now, what happens is the biggest time saver out of all of this. All those materials, you might have only used 3 or 4 nezo materials, and you might see up to 100 rows of data filled into this Excel document. We have identified the material volumes, the carbon emissions data, and converted that back to what building science requires. So you can see a lot of material in here is not in the bales of insulation and the boards of plywood that the quantity surveyor might price, or the square meters of wall cladding, or the cubic meters of concrete that the designer might think about. Things are brought back into cubic meters of chipboard, kgs of steel in your cladding systems, things like that. So all that conversion is done behind the scenes. It happens within the 10 seconds it takes to download that Excel document to your desktop. We change the names back to the reference, the neighbors database, or the source EPD, and we fill in all of these cells. So this is pre-populated for you. We add the EPDs. This is the only way to efficiently use EPDs in the neighbors embodied carbon tool. Otherwise, you have to use emissions factors, which can be less accurate, especially when you know what products you're using in your design. For all you people who have carbon assessors on the team or thinking about having carbon assessors, we actually have a fully qualified and trained carbon assessor, neighbors carbon assessor experience with this tool. So we have the facility to help you through this, and it's a great service then to add on. It saves you time when providing the completion of this tool as a service to your clients. This does the life cycle of the material. So that part is done. You don't even have to think about it. You can come to the results. Not only are you getting upfront embodied carbon A1 to A3, you're also getting the transport emissions and the construction A5 emissions as well. And then beyond that, through the other modules towards end of life. And because we're exporting this and it's being quantified and calculated by neighbors methodology, it means we're all playing towards one single source of truth. It means that the results that came from nezo are the results that come from neighbors, and there's never a disparity between the two. And again, populating those cells for you, it's a huge time saver. That essentially is the workflow, and there's a few minutes for questions, so I think I'll leave it there, Barry.
Thanks all. Appreciate it. It was a really slick demonstration. We don't have any questions coming through on LinkedIn. People tend to be on the quiet side in this demonstration. But I know the typical questions that do tend to get asked tend to be around the materials library being one of them. So there's a fairly comprehensive schedule of materials within the library. But what happens if there's a material that isn't in that library? Something new to the market or something bespoke to that architect? Is it something the user can add, or how do they go about actually selecting material that isn't in the library?
Yeah, if you have a product that you want to use in your design, and you've identified that that EPD is not already embedded into the library of materials we already have, you can add that. So we have a portal you can go to, find that PDF. Or well, usually an EPD comes in a PDF. You can submit that. You can extract the data and put it into the form, or we'll do that for you. Now that EPD is available to use as a material in your design software, and then you can actually form it into a system yourself. So you can go to a pre-existing nezo material for a wall build-up, a wall that has brick cladding, structural bracing, timber frame insulation, and maybe it was a different type of insulation. You can get that new EPD for the new insulation you want to use, swap it out, and now you've not only introduced more carbon data, you've actually built a new composite material. You can apply that to basically slabs for the walls and quantify an entire wall system for a building in a matter of seconds.
Nice. When it comes to the cost data, is that just materials, or is it more than material content? Does it breach into the likes of labor, time based costs as well?
Yeah, good question, because I didn't hit on the holistic costings during the demonstration. So all all cost rates within the system are fully inclusive of material supply and labor install and sundry items that might be associated with that. For instance, things like structural steel and even some structural timbers for that matter, a cost allowance towards the likes of shop drawings and lifting on site would be built into those as well. That's common enough for these kind of cost planning rates that we provide, but a higher level to that as well, and very importantly, with the modern methods of construction we're using it today, like prefabrication, engineered wood products, structural insulated panels, there's a speed factor. So some of these on a cube for cube value, engineered wood versus concrete, one is vastly more expensive than the other. But when you think about speed of construction, how fast you can do a floor for an apartment building, for example, up 5, 6, 7, 8 levels, you start to make a saving on the duration on site. If you have a crane on site, you're saving, 20, 30, $40,000 a month by shaving for 8 weeks off your program. So we actually capture that by accounting for the P&G of your total project cost. So it's the only platform where you will see holistic costings, whole of project costs actually considered to pick up that time saving.
Nice, thanks, Owen. It's also, I know you probably touched on it a couple of times, but the fact that you can use it from concept design. You don't need to wait until you've got detailed design or even preliminary design. You can start from the very beginning and understand how your design is performing right from the outset. So you're not wasting time with redesign loops, as I said previously. When you go into the end of a design stage, you hand it to a quantity surveyor and they do a target check or a budget check to see if you're still on point. I guess having all of that data available to you allows you to always see how you're performing live as you design, making good decisions, which removes the need for value engineering, or at least reduces it considerably. And then on top of that, just reiterating the point that you made around the carbon compliance reporting, so the likes of neighbours, and that it's probably the most helpful thing in there from a time saving perspective. Hundreds of hours on an annual basis on how many projects you're running, and also just removing the headache associated with that carbon in form and that it's correct every single time. Yep. Look, Owen, thanks very much for the demo. To anybody who is attending, what we do is we offer a free trial. It's a 10-day trial. You can jump on and just register with us. Chuck up a link. Should be on the screen now. There we go. So the link is just popped up on the screen. If you just click on that link, it'll take you directly to our contact page where you can request that trial. 10 days free. You can test this out, get them on board, and support us. We'd be delighted to have you guys on board. And because we're early days into Australia, we'll be offering some discounts along the way as well. Please follow us on LinkedIn and please spread the word around these demonstrations. We will start to mix it up as we run out more of these. In the future, we will be not just concentrating on demos, but concentrating on specific projects and subjects that exist within the nezo ecosystem. Thank you all for logging on today. As I said, please spread the word, and we'll see you next time. Thank you.